Okay, thank you again for joining us. So this presentation is the impact of eco-speed control system on driver behavior. That's part of a bigger project that we have been doing with Virginia Tech in the last 3-4 years. And that's part of Samira's dissertation that she just successfully defended. And so Dr. Samira Hungary. Um, this eco speed control system, I let her to do the presentation. I'll just give you an introduction about what it is. So we are looking at giving the drivers um, a speed guidance. So we tell them what should be your speed. So when you approach an intersection, you can pass the intersection in the green light, so you don't stop on the red light. So that algorithm was developed by Virginia Tech. What we did, we brought the algorithm and we put it in our driving simulator, and we wrote, I mean, mostly Samira, wrote the codes to connect that to the driving simulator, and we wanted to see how people react to that and how um, and what is the best way to give that information to them. So with that, we did different ways of giving them the information and different road geometry, and also to see. I mean, it's not part of this presentation today, but we also looked at even different vehicles, light duty and heavy duty vehicles. So I let Samira to do the presentation. I just give you a brief introduction. Samira, is all yours.
Thank you, Dr. Jaihani. Yes, we know that environmental issue is the important challenges in the metropolitan area, especially in the metropolitan area. And the transportation sector is one part that is responsible for such issues. So to reduce the fuel consumption of vehicle, uh, we apply different way. For example, applying information and communication technology like improvement in catalyst, alternative fuels like electric vehicle or engine efficiency. And the other way is eco driving that today we are going to talk about it. Uh, in this we choose signalized intersection because signalized intersection is the hottest spot of the emission. Why? Because they have highest traffic density, the most deceleration and acceleration activity happen in the intersection that we know that deceleration and acceleration make pollution or emission. Also, the most vehicle queue and idling time happen in the intersection. So, reducing fuel consumption at the intersection is important for us. And in this study, we investigate that reducing emission using eco driving at intersection. Uh, as Dr. Jaihani mentioned, this study apply eco-speed controller that developed by Virginia Tech, and we using driving simulator to give announce the information. By information, I mean the speed that calculate based on the algorithm, the optimized speed. If the participant follow that speed, they can pass the intersection without stopping. And as mentioned, stopping and accelerating again make emission. What is the objective of this project? The objective is to investigate the driver behavior in the presence of different eco-speed guidance, because not only eco speed guidance is important, giving information and the result that is decreasing emission is important for us. We want to have a status driving also, so to not distract driving. So we investigate driver behavior and the percentage of fuel saving based on using this eco-speed control system. Also, the percentage of emission reduction. We did a comprehensive literature review to address all the previous limitations that in the previous study using eco-driving for the decrease in emission. We address following limitation like the study area, previous study using that study eco-driving in the signalized intersection usually use one intersection, but in this study we apply multiple intersections. Also, most of the previous study didn't consider grade of the road, but in this study we consider uphill and downhill. The number of participants is another advantages of this study because previous study that using eco-driving and in the driving simulator, number of the participants usually is less than 50, while in this study we have 70 participants. Also, different type of vehicle. The algorithm is applied in light duty vehicle, heavy duty vehicle, and electric vehicle. Another limitation of previous study is regarding providing the guidance. In this study, we make different eco-speed guidance like speed, exact speed or speed change via voice, text, and color that I will explain further. In the literature review, I categorize them in different parts. I don't want to go through them completely. I just shortly talk about it. First, we start with eco-driving. What is eco-driving? Eco-driving is a decision making that changes driving behavior. Like what? For example, that's the feature of eco-driving that are so important. Like accelerating moderately, anticipating traffic flow and signals to avoid sudden starts and stop, because we said that stopping and starting make emission, and that's so important for us. Maintaining driving pace and driving at or safety below the speed limit. Also, the last one is eliminating excessive idling, because this one make emission also. That's some of the recent previous studies that using eco-driving algorithm, and as you see, based on the number of the intersection roadway grade, that most of them didn't use roadway grade, while the Virginia Tech algorithm that we use in this study use different grade. And another summary is related to previous study that using eco-driving and driving simulator. As you see, the number of participants is less than 50, while we have 70 participants in this study. And these papers show some previous study regarding applying eco-driving and traffic simulation, and the last one that is eco-driving and real-world experience. Again, I mentioned that in this study, we use eco-driving, apply eco-speed control in the driving simulator. In the methodology, I'm going to talk about eco-speed control system, what is it and how does it work. Then I will talk about questionnaire, because instead of driving simulator, we have questionnaire also. I will talk about the driving simulator that we use, driving scenarios, different scenarios that we apply in this study, we designed for this study, the participant, how we found participant, and the data collection. EcoSpeed controller, as I mentioned, we use the algorithm from Virginia Tech. In this algorithm, two cases considered. One case is whenever vehicle can pass through the intersection on the green phase without deceleration. Case 2 is when vehicle needs to decelerate to a slower speed and then keep that speed to pass through the intersection. I will show the second case. That's the graph for the second case. As you see, the vehicle should decelerate, then keep the speed to be able to pass through the intersection. Here is the intersection, and it can pass the intersection by this way, and after intersection, it can accelerate to reach the speed limit. This one shows how the algorithm works. I should mention that the algorithm, I said that the algorithm applies for the signalized intersection, and it works in before and after intersection. In area before and after the intersection, that was 200 meters before intersection and 200 meters after intersection. So whenever the algorithm starts EcoSpeed, we call it EcoSpeed controller. Within the range of that is 200 meters before the intersection and 200 meters after the intersection, that's the dedicated short range control. Gather the information about signal phasing and timing, information about vehicle like speed, distance to intersection, and the other information, and the information about the road, grade of the road and the traffic. Based on these three type of information, and look at the traffic signal. If the traffic signal is red, the vehicle should need to slow down based on case 2. And based on the queue of vehicle information, calculate required delay, and based on the fuel consumption model, calculate optimal speed. Because we said that the algorithm calculate optimal speed, but the purpose of this optimal speed is reducing emission. So the fuel consumption and emission is considering this one. After that, the speed will be advised to the driver in different points that different type that I will talk about it. And based on the car following model, maintain headway, and it will be able to pass the intersection without stopping at the back of the intersection for the light. Previous slide showed the algorithm. This slide showed the connection between algorithm and the driving simulator. The algorithm, that is EcoSpeed controller, calculate the optimal speed, or we call it EcoSpeed. This output of the algorithm needs input. The input come from simulator. From the simulator, we have access to different data. For example, vehicle speed, vehicle direction, vehicle location, speed limit, signal offset, and the other information. But one information that is so important, or one of the most important input for the EcoSpeed controller, is distance to a stop bar. That the output of the driving simulator didn't give us this information. So I programming to find this this input and give this input to the EcoSpeed controller. So the EcoSpeed controller algorithm, based on this input that give to it, calculate the echo speed, and then we announce this speed to the driver in different way, as you see here. Recommended speed voice, recommended speed text, speed change voice, speed change text, speed change color, and color coded. I will go through it and explain them one by one later. Regarding questionnaire, as I mentioned, in addition to the driving simulator, we have questionnaire that we have two different questionnaire. One questionnaire we give it to participant before start driving experience. And this questionnaire consists of demographic information like age, gender, work status, educational level, income level, household size, and also their attitude and driving behavior in the real world. I said that before driving experience. And another questionnaire was after the driving experience to find if they like the information that gave us, if it is useful for them, if they are able to follow it, and the degree of distraction they have based on the information they use and the simulator sickness experience. And here you see the driving simulator picture in the Sabo Center Safety and Behavioral Analysis Center at Morgan State University. We have driving simulator. It consists of two parts, software and hardware. The software, the name of the software is VR Design Studio software that provided by Furumate company, and it has capability, as you see here. We are able to simulate everything like real world, like road, all the sign, all the trees, building, traffic sign, light, and whatever that be able to simulate real world. And the hardware, as you see, it's like a real car. It has a steering wheel, ignition key, acceleration, brake pedal, and everything, safety belt, and whatever it look like real car. Here I put that's the study area that I mentioned. The software of the of the simulator is able to put it exactly like a real world. I select an area in Baltimore, and because I consider 3 intersection in this study, and different type of the road, 3 lane and 1 lane. As you see in here, the blue one is 3 lane street with 3 intersection, and the orange line is 1 lane street with 3 intersection. To consider different condition, we have different type of we design different type of scenario. As you see here, we have base scenarios, and as you see here, echo speed, guidance scenarios, and the countdown scenario. For the blue one, they are comparable together, because as you see, for example, we put the base. In the base, we don't have any information. We didn't give any information to the participant, and we only ask them to derive like real world, whatever they do in deriving without any information. After that, we gave them different scenario with different information and different condition. Whatever we consider is traffic type, that we consider 2 traffic type, no traffic and mild traffic. Road condition, we consider uphill and downhill. It is road grade. And number of lane, for the number of lane, we consider 3 lane and 1 lane, as I mentioned, to be able to compare all different conditions together in the base scenarios, echo speed guidance scenarios, and countdown. As I mentioned before, that's the different type of guidance we gave to participants. For the recommended speed voice, we gave them the information of the recommended voice or the optimal recommended speed or optimal speed that calculated by the algorithm by voice every 2 or 3 seconds. And I have to say that we don't force participants to follow that speed to be able to pass the intersection, because the purpose of this study is to investigate driver behavior. We for each scenario, we only tell them that if you will, for example, for the voice scenario, we said that you will hear the speed guidance. If you follow, if you are able, you can follow it, and if you follow, you can pass the intersection. But we don't force them to follow the speed. And in the recommended speed, we gave them the exact speed. For example, 20, 25. But in the recommended speed text, and in the recommended speed text, again, we gave them exact speed that they should follow. For example, like here, 21. Previous one was voice only. This one is text like this. But in the speed change text, we didn't give them the exact speed. We only tell them a slow down, a speed up, or no change. And they have to change their speed, but they didn't know about the exact speed that they have to adjust their speed to. In the speed change color, we use green for speed up and red for a slowdown. And again, because it is a speed change, we didn't give them the exact speed, just this speed up or a slowdown. And for the no change, I didn't bring it here, but we use black. That's the last guidance that we gave to the participant. But I should say that the scenario wasn't in order. We tried to have different of them to different participants to not be in order, to be able to find the effectiveness of the guidance, not the learning point. So in this one that we call it color coded, that was the animated one. The arrows goes up, and the green arrow, whenever the green arrows goes up, means that they should speed up, and the red arrows goes down, means they should slow down. That's the countdown scenario. This one doesn't use the algorithm because we don't give the information regarding the speed to the driver. We only gave information like this, like for the traffic signal to the participant, and they should adjust their speed. For example, here they know that, and it is countdown. They know that from now, 80 seconds, they have 80 seconds for gearing, and they have to decide that if they can pass the intersection or not. And here, as you see, there is 15 seconds for the red one to change to green. The participant, for having participant, we use flyer, online advertisement, and handout flyer that we distribute in Morgan State University and Baltimore, or we email the previous participant that came to our center and was likely to continue with us. We was able to have 70 participants. That was the good number of the participants, as I mentioned before, because previous study that using driving simulator usually have less than 50 participants, and that number of participants is good. The flyer, as you see, contains different information like contact information, a summary of the study, and an explanation of the monetary compensation, because we gave participants $15 for 1 hour driving, and that they help us to do this study. The data collection, the demographic information is like this, show that the number of female and male, as you see, we have 58.6% female and 41.4% male in this study. Regarding the age, we have different age group. Our participant was from different age group, but the most one, that is 32.9 of participants, were in the age group of 18 to 25. Also, we have different participants in different level of education, and most of them, 37.1, was in a graduate degree. Regarding employment status, 57.2% employ full-time, 27% employ part-time, and 15% unemployed. We have good mixture of annual household income also, that less than 2,000 was for 28.6% of the participants. We have information regarding household size. As you see, 40% have 2% in a house. Regarding the following percentage, as I mentioned, before each scenario, we tell a participant to follow the recommended speed, but don't force them, so that this percentage is important for us, because we are going to know that if the participants are able to follow the speed that we recommend them. And as you see, because we have 3 intersections, for each intersection separately, we calculate the following percentage. That's for uphill scenario, that the highest percentage of the following, as you see here, is 76%, that is related to speed change color, because these are different type of guidance that I mentioned before, and we give this information to participants for each scenario. For the downhill scenario, the recommended speed voice has 61%. And the other reason that we using different 3 intersections, we are going to investigate if the percentage of following is different or increase in second and third intersection after first intersection. But in the uphill scenario, we couldn't find such a expectation. In the downhill scenario, but it was, as you see, the following in the percentages in the first intersection was 61, while it increases in the second intersection and third intersection. For the emission, regarding the emission, again, for each intersection separately and for different scenario, here we have base scenario and countdown also. As you see, in comparison between base scenario, echo speed guidance, and the countdown scenario, the most emission is for the base scenario, and the least one is for the speed change color. That we selected this as the best type of the information provision. Our previous one was for the uphill scenario, emission regarding downhill scenario. We found the same result. As you see, the most emission is for the base scenario and the least emission is for echo speed guidance system. And the countdown, as you see, is between these two. Again, for different type of the emission, that's the same one, but for example, for color code scenario, that's the result that are significant. I only put the significant result comparing different emission of different scenario, base scenario, echo speed guidance scenario, and countdown scenario in each intersection separately. And as you see, I color the most one, the highest emission with the red, that is related to base scenario in all the different scenario. In color code scenario, recommended speed text scenario, and also in speed change text scenario. As you see, the worst one was for the base scenario, and the best one is for the echo speed guidance, or here speed change text. Based on these data and all the analysis that we did, we find a model to find what feature are effective in following percentages. We found type of echo speed guidance, grade of the road, traffic condition, gender, and age group as effective features in following percentage. For example, in the type of echo speed guidance, we consider a speed change voice as a reference category. And comparing to reference category, we found that speed change color and color code has more following percentage than speed change voice. And the other one has the less following percentage than speed change voice. To summarize here a little bit, as I mentioned, we have two types of announcement. Recommended, we name it recommended speed and speed change. In recommended speed, we gave the exact speed, and in speed change, we only say speed up, slow down, or no change. As you see, we have better following percentage in speed change instead of recommended speed. Also color instead in comparison to text and voice. Because of these, we have the speed change color as the most following percentage. And we know that the better they be able to follow the recommended speed, the reduction in emission and fuel consumption would be more. Regarding the grade of the road, because we consider uphill as a reference category, and as the result show, we find the significance result for the downhill, that following percentage for a downhill scenario was significantly more than uphill scenario. Regarding traffic condition, the following percentage of mild traffic, as you see here, in comparison to no traffic, was less than that. Was expected because in the mild traffic, there are different vehicles that maybe it's difficult to adjust their speed to be able to follow the recommended speed or optimal speed to be able to pass the intersection. Regarding the gender, we found that the following percentage of male is more than female based on this study. And regarding the age group, we found significance that whenever the reference category is 56 to 65, as you see, the following percentage in the other age group are less than 56 to 65. That we can say that this related to because this group has more experience, while the younger driver doesn't have a lot of experience in driving, and also they have a speed. While this group, they don't speed up, that they can better follow the recommended speed or adjust their speed based on the recommended speed. That's the model that we found based on this study. And I put only some questions from the questionnaire from the survey that we asked participants to do it. For example, regarding usefulness of eco-speed guidance, it was good that only 2.9% mentioned that it isn't at all useful, but 30% said that it is extremely useful, 26% said that very useful, and 22% said that somewhat useful. Regarding easiness of following, again, only 4% said that it isn't at all easy, but most of the percentage here show that it is easy to follow. Regarding what kind of speed, eco-speed guidance the participant prefer, we have two different type of guidance: exact speed and speed change. As you see, 62% mentioned that speed change is better, and the their driving experience is aligned with their survey, with the survey. Because in the driving experience, we found speed change better than exact speed. And regarding which type of guidance do they prefer between color, text, and voice, 52 mentioned that they prefer color display, that again, it is aligned with their driving experience. But regarding which type of eco-speed guidance or countdown do they prefer, it is interesting that 38% mentioned that they prefer countdown, and it is different from the driving experience. And maybe it is related to, because in the countdown scenario, we don't give them the speed. They have to adjust their speed, and because of this, they like to adjust their speed themselves, and they think that they can adjust it, but the result from the driving doesn't show that part. Regarding to what extent eco-speed guidance is distracted, because it is important, even if 100% are able to follow the guidance that we gave them, but if they distract them, we cannot choose this one, because we have to, this study done to select a type of information guidance that is not distracted, and it is safe and it is effective. So both of them should be applicable. And here, as you see, 16% said that it isn't at all distracted, and only 9% it is mentioned that it is extremely distracted. 37% said very distracted, 20% said that somehow distracted, and 12 said that slightly distracted. Regarding the deriving behavior, because we have one question regarding aggressiveness, and the result was interesting because 38% said that they are somehow somewhat aggressive, and only 16% said that they aren't at all aggressive. The results showed that most of the participants were aggressive, unfortunately. And I just summarized the conclusion from the first, whatever I forget to mention about it. In this study, we have a speed limit of 30. The number of intersection was 3. The traffic condition, we consider no traffic and mild traffic. The grade of the road, we consider uphill and downhill. And the traffic signal was fixed for this study. The scenario, we have different type of scenario: base scenario, 6 different type of eco-speed guidance scenario, and countdown scenario. For the eco-speed guidance area, as I mentioned, we consider 200 meter before intersection and 200 meter after intersection. And the number of participants was 70. Percentage of male participant was 41.4%. And different type of eco-speed guidance I mentioned here. We have 6 different type of eco-speed guidance. Regarding effectiveness factor, that we found a model for it. We find age, gender, type of eco-speed guidance, grade of the road, and traffic condition as an effective factor in the following percentage of the following. And the following percentage was up to 76%. That was the best one, was for the eco-speed, for the speed change color. And the emission reduction, we found up to 7% reduction in emission. Regarding the limitation of this study, for this study, we didn't test the autonomous version of the vehicle, that the driver could give the vehicle control to the system. So it is suggested for the future study. Regarding the sample, when we apply the eco-speed guidance for the heavy vehicle, light heavy duty vehicle, light duty vehicle, and electric vehicle, but for the heavy duty vehicle, we couldn't find participants that are really driver of heavy duty vehicles. So for the future work, that was one of our limitation, and it is suggested for the future work, if they are going to work with the heavy duty vehicle using simulator, is better to have participants that are driver of the heavy duty vehicle. And for this study, the other limitation was regarding signal timing, that we use fixed signal timing, but for future work, we are going to apply the actuated signal timing that is sensitive to the traffic condition. The other limitation is regarding driving simulator. We know that driving simulator has a lot of advantages to real because we cannot do some study in the real world, so but we are able to use driving simulator. But the situation is different, somehow different from real world. So it is our suggestion is to do such a study in a real world, especially right now that we found the best type of guidance as as a speed change color, like this speed up with the green and slow down with the red. Our suggestion is to apply this guidance in a real world to see the result. And the last suggestion for the future work is, because in this study we consider different type of the eco-speed guidance separately. We study them separately. Our suggestion is to combination of speed change color that we found it as the safest and the effective one, and voice together in the future. Any question? Dr. Shehan, you're muted if you are talking.
Oh, sorry. Thank you so much, Samira, for the presentation. Any questions, audience? And thank you everyone for joining us. And that would be great if you ask your questions. Um, I have one question, or maybe it could be for the future. We could also test, maybe you said that, test the if it is automated, if it becomes automated at the intersection and passes by itself.
Yes, I mentioned as one of the limitation of this study.
Okay. Okay. Thank you very much. It seems there's no question. Thank you, Samira. Thank you, everyone, for joining us and listening to our presentations.